Hello guys, and welcome back to our YouTube channel. So in this video we're gonna go through the correction of one exercise I gave to students, and I see many methods that students were using and at the end still having the wrong thing. Anyway, so in this video we're going to solve this polynomial equation that is given that the polynomial p of x of degree 3 and that p of x leaves a remainder of 12 and negative 8 when divided by x minus 2 and x plus 3 respectively. Find the remainder when p of x is divided by x squared plus x minus 1, that is a. Given that x minus 1 is a factor of p of x and p of 0 equals to negative 2, find the quotient of p of x when it is divided by x squared plus x minus 6. Express p of x in the form of ax cubed plus bx squared plus cx plus d. Voila, this is a very nice question. Anyway, when we talk of polynomial degree 3, just need to write the terms from x to the power 3 right up to x to the power 0. That is, we should have like this: x to the power 3, x to the power 2, x to the power 1, right up to x to the power 0. So now you can just put maybe coefficient our ax cubed, maybe plus bx, maybe plus cx, maybe plus d. Anyways, all of us know that x to the power 0 is 1, so we can just gently write this one as d. That is the meaning of a polynomial of degree 3. So this is now the polynomial p of x. I can just take it like this. So this question, I want to solve it recursively. I want to begin from the end part to the first part. That is, I want to begin with c part. And you can also do that in your GC examination. Make sure you number your work very well. Now let us move to the question gently. Let us say our c part, express p of x in the form of that, where a and where these are constant and so on. So let us now begin. So they told us that x minus 2 leaves a remainder of, so x minus 2 a remainder of negative of 12, since they say respectively 12, then x plus 3 a remainder of negative 8. So these are the conditions we have been given. We have also given that x minus 1 leaves a remainder of 0, that is, it is a factor. Then p of 0 is giving us p of 0 gives a remainder of negative 2. So these are the 4 conditions that we are having. So I will just simply substitute all of these 4 conditions into that my polynomial. So I will now say that you know that x minus 2 is a remainder, gives remainder of 2. Then p of that is x minus 2 equals 0 implies x equals to 2. It implies p of 2 will now give a remainder of 12. That is, p of 2 will now be equals to 12. So that is what I will apply here. I will apply p of x equals to negative 3. Here p of negative 3 equals to negative 8. Here p of 1 equals to 0, and here we'll be applying p of 0 equals to negative 2, and that is just what you will do. So let us go ahead and just substitute everything. Anyway, let me pause the video and do that. Okay, let me not make the video lengthy. So I've just simply paused the video. I've just started with x equals to 2. When x equals to 2, we just get a into 2 cubed plus b into 2 squared plus c into 2 plus d equals to 12. That is what the condition, that is the first condition. Then the second condition is simply p of negative 3 equals negative 8. So we substitute a into negative 3 or cube plus b into negative 3 or squared plus c into negative 3 plus d equals to that. Then the third condition is x of equals 1, where that is p of when x negative y is a factor. So x minus y is a factor, and then p of 1 equals that a into 1 plus b plus c plus d equals to 0. Then when p of 0 equals to 2, so you just simply substitute x of 0 equals to that. And from the last equation, that is from equation 4, we just see that our d equals to negative 2. 0 times all of these terms disappears. All of these first terms disappears, and all of these terms disappear. We just get d to be negative 2, and I'm going to substitute in all the rest of the 3 equations d equals to negative 2, and then you see how we're gonna go about it. So let me pause the video once more. Voila, so this is what I got. I just simply got 8a plus 4b plus 2c minus 2 equals to 12. That is a substitute. When I substitute for d equals to negative 2. Similarly, I've just done it here. D equals to negative 2. So I've just simply expand this. Please just look up what I've done. I've just simply taken, this is negative. This is when x is equals to 3. So we have negative 27, negative 3 cubed. Then here, negative 3 squared is negative 3 times negative, that is 9. Then I get negative 3c. That is this here, and the other one similarly, and the last equation. So now I'll just go ahead and arrange these equations. From the first equation, I'll just simply divide everything by 2. That is to make my coefficient to really come down so that I can do my easy substitutions. So I'll just go ahead and divide equation 1 by 2. I'll divide this equation by 2. I'll divide the second equation by 3. Then I'll divide the last equation by nothing, or by 1. Then you look at how it will then look like. Voila, just look what you have done. I've just simply divided equation 1 by 2. I got 4a plus 2b plus c equals to 14 on 2, which is 7. Negative 9a plus 3b minus c equals to negative 6 on 3. Just see, I've just simply taken this 2 the other side. I've simply taken this 2. It will be negative here, becomes positive. We get 40 on the right hand side. That is it. And the other one, negative 2 goes on the other way. We get negative 2 plus 2. That is negative 6. This is it. And I've divided all through by 3. I think you can see it. For the second equation by 3, while for the first equation by 2. So now I can now simplify my equations to look something like this. So get 4a plus 2b plus c equals to 14 on 2. I think is 7. Nothing to argue. 9a plus 3b minus c equals negative 2. And I get a plus b plus c equals to 2. Voila, so these are my equations. Now what I will do, I just simply make c the subject in the last equation. Always try to make the one that does not have a high coefficient. That is, if you go, you are making b the subject, you're going to substitute b up there, be multiplying by 3b and 2b up there. So let us just make c the subject. So c from equation 3, c equals 2 minus a minus b. I'll just sub in 1 and 2. I'll just sub in 1 and 2, and then I'll just be having a and b, and that will be a simultaneous equation that can be solved by a form 3 student. So let me just substitute there in equation 1 and 2. Voila, so this is just what I've got. I just simply substitute the c equals 2 minus a minus b. I just simply substitute it here. We are now having this plus c. Now I'm now having the 2 minus a minus b. So I simply substitute that. Then I also substitute the next one is negative c. The negative remain intact. I'm just substituting for c. So bracket comes here and I substitute for c. You see the braces, they are very, very huge. Well, now I just simplify the first equation. I get 3a plus b. This is 2b minus this b. This is positive, negative remains minus. 2b minus b gives me b. So 4a minus a gives me 3a and minus b. 3a plus b equals 7 minus 2. This 2, I take it the other way, and I got 5. Similarly, I just did negative 9a. Negative a gives me positive. I get now negative 9a plus a, which gives me negative 8a. Now I got 3b. Minus b is negative. That is 3b plus b. That is 4b. Then the negative 2, that will, when I open the bracket, I take it the other way, will meet the other 2. So negative 2 plus 2 gives me 0. And I got this two nice simultaneous equations that are very, very easy to solve. So now I can say that from equation 1, this is equation 2 by the way. From equation 1 again, I see that b is simply 5 minus 3a, and I just come and substitute here subs in equation 2 again, or you can just be calling the equation 2, 3, 4 and so on. Negative 8a plus 4 into your b is 5 minus 3a, and all of that equals 0. And I got negative 8a plus 4 times 5 is 20 minus 12a equals 0. That is 3 times 4 is 12, or 4 times 3, but negative is hanging. So I got now negative 8a minus 12a. I get negative 20a equals to negative 20. I just simply take this 20 the other side, and I divide both sides by 20. And I simply get my a to be negative 1. Very easy. Now that I've gotten a to be negative 1, I just go gently. This is my first equation. That b is equal to 5 minus 3a. And now it'll be 5 minus 3 into negative 1. Right? I'll now be getting a will be equals to 1. Sorry, because this negative cancels. So we'll be having a into 1. That is 5 minus 3, which will give me 2. So that is my b. b equals 2. And now I go to my c. I just got that. I said that c was equals to 2 minus a minus b, isn't it? So I got my c to be equals to 2 minus a minus b. C was 2 minus a minus b. Now it will now be 2 minus 1 minus 2. And I simply get 2 minus 2 is 0. I get c to be negative 1. And now my polynomial p of x in the form of ax cubed plus bx plus c, I will now be getting by what? A is simply negative 1. A is simply 1, so we just have a 1x cubed. Let me change my red pen. So we'll now be getting x cubed plus bx squared, and b is 2, so it is plus 2x squared, minus plus cx, and by my c is negative 1, so minus x, plus d, we got d to be negative 2. So this is now my polynomial. Before I continue, I have to verify at least 2 or thrice. So we got the condition that p of 1 equals 0. That was the first condition that we were given. So let us try it. P of 1 have to be equal to 0. Is it true? So we get 1 cubed plus 2 into 1 squared minus 1 minus 2. Minus 2, what is that equals to? 1 cube is simply 1. 2 times 1 squared is simply 2. So we get 1 plus 2, which is 3. Then we get minus 1 minus 2. This is 3 minus 3, which is equal to 0. It means we are correct at this stage. What about p of 0 equals to negative 2? Can you try it? I think I'm very, very correct. So let us continue. Okay, B part is saying that find the quotient when p of x is divided by x squared plus x minus 6. Let us find the quotient. And A is saying that find the remainder when p of x is divided by x squared plus x minus 6. We are just dividing by the same thing. We need the quotient and the remainders and norm them as our answer for A and B. So let us just go and do it using the long division. So this is how you set the long division. You take your p of x and you divide by x squared plus x minus 6, and you simply get your result up there, hanging up there, to be q of x, which is known as the quotient, and the answer down here is our remainder. So you see how we just do that one part and everything is done. So let us just go ahead and write it down. So we have our polynomial, which is x cubed plus 2x squared minus x minus 2. We are dividing that by x squared minus x plus 6. Oops, is it plus x minus 6? Let me verify it. Voila, here it is. So let us just simply do it. So we just simply take the highest degree here. Make sure, please, your polynomial have to have x to the power 3, x to the power 2, x to the power 1, right up to x to the power 0. Then before you can divide it in this side, even if it is x cubed, you have to add 0x squared plus 0x plus 0 to make it that in that manner as a polynomial. So now let us divide x cubed by x squared. X cubed dividing by x squared is simply x to the power 3 minus 2, which is simply x. That is indices. So we just get here x. So we just simply get here x. So if we get here x, the very important thing with video, I've erased it. You can still post and take your screenshot. So we have our x here, and then x times x squared gives you x cubed. X times x, you simply now multiply all terms and you simply write under x times x is x squared. You come under x squared, you write it, but it is positive. You write your x squared. X times negative 6 is simply negative 6x. There is nothing under the constant. Align like that. You realign, you do your subtraction. X cubed minus x cubed is 0. 2x squared minus x squared is simply x squared. Negative x minus negative 6x is simply negative x. Let me write this one. They are always confusing. Negative x minus negative 6x. This one now becomes positive. Negative x plus 6x. This one is still confused. I can write it as 6x minus x. This is 5x. So you can now come ahead and you have your 5x here. Gently. That is, but it is positive 5x. Now your negative 2 comes down, and you see the degree here is still less or equal to this. You can still do your division. So you still take x squared dividing by x. You simply get 1. That is x squared dividing by x squared. You simply get 1. 1 times x squared, you simply get your x squared. 1 times x, you simply get a positive x. 1 times negative 6, you simply get a negative 6. You realign and you subtract. X squared minus x squared is 0. 5x minus x is simply 4x. And negative 2 minus negative 2 minus 6. Negative 2 minus 6 is just as negative 2 plus 6. 6 minus 2 is 4. So we get positive 4 here. So this is now what I have gotten. In other words, I can now compare my solutions. They are telling me that we should find a quotient. So I will now say my quotient is equals to what? X plus 1. The answer up here, we say that it is your quotient. This is it here. I stated clearly, this is my quotient. And now the next part I'm going to find is the remainder. What is the remainder? The remainder is the answer down here, which is what we call our r of x. That is a function of r, remainder. So B was to find the remainder. So you can say remainder equals to 4x plus 4. Please, if you find this video helpful, like this my YouTube video. Please share this video to all your friends. Subscribe to the channel. Thanks for watching.